Hello everyone, it's me Amna and welcome to Amna's Learning Hub. I hope you all are fine and following my videos. So today I'm here with lecture number 3 on states of matter, and this is going to be the last lecture on states of matter. In previous lectures we discussed about different states which were solid, liquid and gas, and after that we studied about conversion of these states. Now today we are going to discuss about the graphical representation and the melting point and the boiling point and the freezing point of all these states. What are these points? How can we identify them? And how these graphs helps us to understand how the liquid is converting into gas, a solid is converting into liquid. So let's start. So first of all, if I revise the previous one, so we discussed about solids which is converting into liquid, which is converting into gas. So solid which is converting into liquid, this process is known as melting, and liquid is converting into gas is known as boiling or evaporation. So first of all, we are going to study about melting. That what is melting and what are the energy changes that we observe while we observe the process of melting. So here you are discussing about melting and energy changes. Okay, if we discuss about energy changes, so I hope you all remember when a solid is converting into liquid. Let's discuss it with the help of graph. This is a graph. Graphs has always two axes. This is origin point, this is y-axis, and this is x-axis. So on x-axis we always take independent factor. So we are taking time here. And on y-axis we are taking temperature in degrees Celsius. So now I am going to give you an example of melting. That means some solid is converting into a liquid state or a gas state. So the example of solid that we are taking here is stearic acid. You can take any example, but your point of melting point should be correct of that. So if I talk about stearic acid, the melting point of stearic acid is 69 degrees Celsius. So we are having stearic acid and we are going to start the process at room temperature. So this is the zero origin. So somewhere here will be our room temperature. So process is going to start here. So we are providing heat. So here we have a beaker. For example, we are having some stearic acid in beaker and we are going to provide some heat here. So this is the point A, from where we started the process of providing heat, and we are providing heat till the temperature is increasing, and we are providing heat till it stops here, the first stop. This is point B and this is 69 degrees Celsius. So this is the point where melting starts. 69 is the temperature where stearic acid melts. So this is the point where melting starts. After this point, the graph will be constant. That means this is the point B and this is the point C. That means in between point B and C, the temperature is not increasing because it is continuously trying to overcome the intermolecular forces present in the solid. We know that in solids, if I divide this. So if you remember the diagram of solid, this is the diagram of solid and particles are quite close to each other. That means when the particles are quite close to each other, the intermolecular forces between the particles are very strong, and to overcome those intermolecular forces, temperature is constantly increasing. So that is why all of the temperature is utilized by these intermolecular forces to overcome the bond between the molecules. So from B to C, the temperature is constant, and this is the time where all of the molecules of solid is going to convert into a liquid. If I show the diagram of liquid, it looks like somehow this. The molecules are now a bit far from each other and they are continuously moving. They are continuously vibrating because temperature is continuously providing to them. At point C, at this point, now all of the solid stearic acid is converted into a liquid. After this point C, temperature will still going on, still increasing because we are still providing heat. Now all of the liquid is converting into gas, and this is the point D. So after point C, now state of matter will be gas, and if I draw the diagram of gas, it will be like this. Now molecules are very far from each other. So the concepts that I gave you in the previous lecture are all justified here. You know, the solid molecules are very close to each other. We are providing heat. We are continuously providing heat till point B. At point B, 69 degrees Celsius, the solid is starting converting into liquid. From B to C, here we have mixture of solid and liquid, because some of the molecules are converted into liquid and some of the molecules are still in solid. So this is the phase in which we have a mixture of solid and liquid. At point C, all of the solid is converted into liquid, and after point C, now this liquid is converting into gas. So with the help of this diagram, with the help of this graph, you can understand how a solid is converting into liquid, how it is converting into a gas. And if you remember energy change, to what we are doing, we are providing heat, and if we are providing heat, that means melting is an endothermic process. I hope this is clear to all of you. Okay, now the next topic that we are going to study is the reverse process of the previous one, which is freezing. Freezing means we are converting a gas or a liquid into a solid. So basically, the process that we studied in the previous slide or the previous board that I discussed about melting and the whole process of stearic acid. Again, we are going to have stearic acid. The temperature is 69 degrees Celsius, at which it is converted into a solid. So now freezing and energy changes. The whole graph that we discussed will be reversed now. Again, we are going to draw the diagram, the graph, y-axis, x-axis. This is y-axis, this is x-axis. On x-axis we are taking time, and on y-axis we are taking temperature. I'm just writing it its unit, and this is the origin point. Now the graph is starting from here. The starting point of the graph, we are representing it as a W. This is the point where the stearic acid is in the state of gas. Now point W. Now what we are doing, again we have a beaker, covered beaker, and now we are decreasing the temperature. We are decreasing the temperature of the particular substance that we have, the stearic acid, which is in gaseous state right now. We are decreasing the temperature. So by decreasing the temperature, what we are doing, we are extracting some sort of energy, and when we are extracting some energy, the motion of the molecules decrease and molecules will start coming close to each other. So if I draw the diagram of gaseous state, the diagram will look like this. These are the molecules of gases very far from each other. So we are extracting some energy, we are decreasing the heat, we are basically cooling this whole mixture. So from W, the temperature is decreasing, we are doing cooling, and this is the point X where it started converting into a liquid. So X is the point where it started converting into a liquid. Now again, there will be a constant period in the period in which all of the gas will be converted into liquid. So from X to from Y, the temperature is constant. That means at this point we have mixture again, but now the mixture of gas and liquid. Point Y, this is the point where all of the gas is converted into liquid. At this point W to X, we have only gas. At this point from X to Y, we have mixture of gas and liquid, and at point Y we have only liquid, but we still cooling it, we still extracting some energy, we still want our desired product, which will be stearic acid, and stearic acid is in solid state. So at point Y, now the temperature is decreasing, and this is point Z. Point Z will be at 69 degrees Celsius. So 69 degrees Celsius is the temperature where freezing occurs. This is the temperature where all of the liquid has converted into a solid stearic acid. So if the question will come, what is the state of matter between point X and Y? If they've given you any graph and they ask you what is the state at any particular point, so you can easily tell now what will be the state at W, what will be the state between W and X, what will be the state at X, and what will be the state between X and Y, and what will be the state at Z. At point Y, the liquid has started converted into a solid. So point Y to Z, now the liquid and solid both are present between these 2 points, and Z is the point where all of the liquid has converted into solid. So this is the reverse process of melting. Melting means solid is converting into liquid, and then liquid is converting into melting basically means solid is converting into liquid, but I just told you the whole process. If it is converted into liquid and we are still continuously providing heat, that means it is then converted into gas. Again here, the gas, we started it from gas, and when first gas is condensing, and then it is converting into liquid, and then it will be converting into a solid. I hope these two changes and the graphs are clear to all of you. If you still have any question, you can ask me, you can message me on Instagram, you can ask me on YouTube, you can try to contact me anywhere, the platforms that I gave you. So now you can even take the screenshot so that the concept will be clear to you. One more thing, whatever I'm teaching you, write your notes, because chemistry is the subject, the point where the moment when I'm explaining with the whole thing, you will understand it, but after 2 to 3 days you won't be able to revive the whole concept. So it is better to write the concepts, even the points that I'm speaking, write them down so that it will be clear to you, and you will have your own notes when you will be needed. So I am drawing the diagrams as well. At this point we have gas. Here the major state is liquid, and after Y the major state will be solid, where the molecules are so close to each other. I hope these two concepts are clear to all of you. Okay, up till now we are done with all of the changes of states and the states of matter and solids and liquids and energy changes and intermolecular forces and whatever the concepts that we have in states of matter. Now one concept is left, and that concept is very important. That concept occurs in everyday life around us everywhere. So I am going to explain that process and factors of that process which affect that. So the topic that we are going to study is diffusion. Very important and very easy topic. Diffusion. What do you understand? What will be diffusion? Diffuse. Something is diffusing. Diffuse. What is it? So basically, you must have two words in your mind when you have diffusion. One is spreading and other one is mixing. When you have these two words in your mind, that means you know the definition of diffusion. So the definition of diffusion is the process of spreading and mixing of liquids and gases is known as diffusion. So first two important points that you have in your mind is spreading and mixing. That something is spreading, first spreading and then mixing. Second important thing is states. So if I talk about states, there are only two states in which diffusion occur, and that is gas and liquid. You know why? Because we studied the arrangement of molecules in solids, liquids and gases. We know that in gases we have large space, so molecules can easily mix and easily spread. In liquid there are some spaces, that means molecules can easily mix with each other. But in the case of solid, the molecules are tightly packed. So when the molecules are tightly packed, they won't be able to mix with each other. So diffusion's definition will be the process of mixing and spreading of liquids and gases is known as diffusion. So by memorizing these four words, you will be able to learn the definition of diffusion. And if you have seen the past papers, there are multiple times when they ask the definition of diffusion, 1 mark question in your subjective, and in objective, in MCQ type questions, they ask you about diffusion by giving different categories or different states or different conditions. I will attach some questions in the end of the video. Try to solve them and answer me. Okay, I hope this is clear to all of you. The process of spreading and mixing of gases and liquids is known as diffusion. So this is the definition of diffusion. Clear? Now we are going to study about the factors of diffusion, that on what are the factors on which diffusion is depending on. So the factors on which diffusion is depending are temperature and molecular mass or molar mass. So first of all, how temperature temperature is affecting diffusion. If you revive the concept I gave you of solids, liquids and gases, I told you that when we are increasing temperature, we are increasing energy. So when the energy is increasing, the molecules will continuously spread, and continuously they will collide with each other. And when they're continuously colliding with each other, the probability of mixing something else into that is increasing. So when the temperature is increasing, that means the motion of the molecules are increasing. So when the motion of the molecules are increasing, it will provide more spaces to mix something else into it. Second thing is molar mass. So first of all, we must know what is a molar mass. You will be provided with the periodic table in your paper. So if you have a periodic table, you will see, for example, I am giving you an example of chlorine. Chlorine has atomic mass which is 17, and then atomic number will be okay. So I am going to give you an example from your periodic table. For example, you have argon, which is a gas. You will have atomic mass and atomic number of that particular element. So atomic number will be 10, atomic mass will be 20. Remember one thing, whenever you will have periodic table in front of you, the value which is smaller will be atomic number, and the value which will be larger will be atomic mass, because the atomic number is only has number of protons and atomic mass has number of protons plus neutrons. So when we have smaller value, it will be atomic number, and atomic number is represented by Z. And when we have larger value, that is atomic mass, and it is represented by A. So whatever the compound, the element, the molecule you will have, you can find out their molar mass by simply adding their masses, and the mass is the value which is larger one. So now I am going to give you an experimental example in which you will understand how the rate of diffusion is depending on mass. Okay, let me tell you a relationship as well. Temperature is directly proportional to diffusion. That means when the temperature is increasing, diffusion is increasing. When the temperature is decreasing, diffusion is decreasing. If I talk about molar mass, so molar mass is inversely proportional to diffusion, because when the molar mass increasing, the mass of the molecule will be increased, diffusion will be decreased. For example, if I give you an example of two people, one is healthy, like it have a very fatty, healthy, obese, whatever you say. So it has the body mass of the person is 120 kilogram. And there is another person whose body mass is 60 kilogram. So which one will run faster? The lighter one. So same is the case with diffusion. If the molecular mass is increased, diffusion decrease. If the molecular mass is less, diffusion will be more. Let's discuss it with the example of an experiment. Okay, so here we have a tube, any tube, in which we are going to carry out the experiment. From this side, we have a source of hydrochloric acid, which is a compound, and acid as well. From the other side, we have another source from which we are infusing ammonia. So both of these compounds, both of these molecules will start moving towards each other, because the experiment is that when the both of the molecules will move and they will combine at a point and they will produce a product. So hydrochloric acid and ammonia, when they both will combine, they form NH4Cl, ammonium chloride. So now we are going to discuss, and now we are going to study which one will move faster. We have hydrochloric acid and we have NH3. Okay, now you have periodic table in front of you.
So here is the periodic table. You can see each element has two values. One is lower and other one is higher. The lower one is atomic number and higher is atomic mass. We are simply adding atomic masses and we are getting values. So 17 is for ammonia and 36.5 is for HCl. That means the more mass, less diffusion, less mass, more diffusion. So you can find the rate of diffusion here. Now I am going to upload some reinforcement questions from past papers. Hope you will understand them and solve them.